actually, so last day I have arranged special session, which is a recorded lesson for this data representation part, which was there in grade 10, and which is going to be, again, we have to discuss that in our graphic lesson. So that part we discuss as a video lesson because it's a basic thing, fundamental, but anyway, it's very important. Please go to the video and watch it again and again. And if you have any question, you can let me know, then I can answer during the class time. Right, okay, so with that, and we will be moving to the new lesson. So that is our second lesson in grade 11 book. So please open the book and let's go to the second lesson, which is system development, right? Software development and system development life cycle. Chapter number 2. Video lesson, actually, I have forwarded that to your group. Didn't you get that through group? So I have already forwarded that to the group. If you miss, right, system development life cycle. So before we begin, I would like to ask, what is a system? So this is actually from your previous knowledge. You can answer to this question using your previous knowledge. System development life cycle. Okay, so what is system? What is system? Can anyone explain the term system? Okay, I can give you an example. Respiratory system or digestive system is a system, or transportation system is a system. Okay, so can you define it? So what kind of features, what kind of components or subdisciplines, or how you define a system? Joel? So what is a system, Joel? Lashain, what is a system?
A collection of parts.
Collection, yeah, a collection of parts, components. A collection of parts, components. Okay. So, Ranvidu, what is a system? Yes. Ranvidu, what is a system? Other than that, okay. So you can write down over there. A system is. So as you said, it's a collection. Yes, a system is set of interrelated. That is very important. Set of interrelated components works together to achieve a common goal. So it's a set of interrelated components working together to achieve a common goal. So that is a system. So very important, interrelated and works together and common goal. That is a system. Okay, please write down over there. System development life cycle is the heading under that. So what is system? What is a system? So you can write down. So example, as example, you can say respiratory system. Respiratory system. So in respiratory system, so what are the set of components? We have nose, you have throat, and lungs. Nose, throat, lungs. So what else? Yes. Nose, throat, lungs. These are the components or parts. And those are working together. Yes. Etc. And those are working together to achieve the goal of respiration. So let's take a computer system. In computer system, you have hardware, software, and liveware. Those are also working together to achieve the goal of electronic data processing. Electronic data processing. That is the goal. So here, actually, this is a theoretical lesson, so you have more notes. So see me, not unlike the previous one, we did some practicals. Here you have to write some notes under second chapter. So here, hardware, software, and liveware, those are the components working together to achieve the goal of electronic data processing or producing information. From data, using data, producing information using data. Okay, please write down these things. Okay, you know that. So computer system, what is a system? So you know the examples: computer system, respiratory system, and also you should know what is hardware, subsystem. So what are the components in hardware subsystem? Hardware is also a subsystem. So what are the components in hardware subsystem? Yes, you know that. Input, output. Yes, name it. Input, output. What else? What else? Input and output only. Proving. What are the other components? Yes. Yeah.
Process.
Yes. Processing. Memory. Storage. And communication. Those are the components in hardware subsystem. And when it comes to the software subsystem, when it comes to software subsystem, you have instructions, documentation, and data related to system and application software. So that is system software. Actually, system software including operating system and utilities, drivers, and system software, OS, operating systems, utilities, drivers, and you have embedded software. All these things together form the software subsystem. And what about liveware subsystem? Liveware subsystem, it has components like users, developers, engineers, sellers, support staff. All these things, all these people are coming under liveware subsystem. Teachers. Right, you can write all this information under the computer. Computer system can be further divided into 3 subsystems, that is hardware subsystem, software subsystem, and liveware subsystem. Those are the subsystems available in the computer system as a whole. So now you know the full story of a system. Right. Please write down this. Right now, you know what is the system and what is hardware, what is software, and these things. Now you know, right? So what I really want, so now our main topic is to discuss about system development life cycle. So we know what is a system and why we know what are the components of the system now. It's very well. So basically, basic element of a system. So in any system, you should have input, process, and output. So in computer system also, we have input, process, and output. So what we input in computer system? So or information system, what do we input?
Data.
Yes, we input data. And what do we output?
Information.
Information, right? So we input data and produce information in computer system. So who suggested that model? Who's the person suggested that model? Input, process, and output. He's called father of computing. Who's that? Charles
Babbage.
Yeah, Charles Babbage suggested this input, process, output using his analytical engine, and that is called Babbage's. So that's why Babbage is called father of computing, because for the modern computer concept, so input, process, and output, he was the founder, and his foundation was in 1980s. Sorry, not 1980s, 1830s. His foundation he put in 1830s. Then it was developed to actual computer by Harvard University in 1940s, after 100 years. He suggested the concept 100 years ago. After 100 years only, they developed the computer using his suggestion of analytical engine. Okay, so now here there's an example given in school system. So system name is school system. Objective is to produce responsible, worthwhile, just citizen to the society. So that is the object. And input is children, process is teaching. Actually, there are a lot of components: teachers, school, materials, classrooms, books. All the materials are there in the system to guide this objective, to produce responsible, worthwhile person to the society. And output is a providing good citizen. So basically, I think you can get the idea from that example. And computer system also, so we have similar features, similar thing. And so important thing here is to study about the computer-based system and manual system. So manual system means a system which doesn't use computers. It uses manual methodologies suggested by human beings. But the issue is, so with the computer system, efficiency is really, really high. So you have to remember these points, right? In computer system, high efficiency and minimum errors. So on the other hand, more errors because it's manual process by people. Here, efficiency will be low because manual process by people. And large amount of data can be processed. Large amount of data can be processed and stored in a small physical surface. Hard disk is very small, but you can store terabytes of data over there. So assume that I have seen in most of some lawyers. So basically in Sri Lanka, most of the lawyers, they have a separate office room, keeping a lot of documents. Actually, documents are like, it's like overstacked. Everywhere you can see documents related to various court cases. And in schools, even I have seen, there are some classrooms filled with all books. So what if we can give a PDF to the students and a tab? So will be more convenient. Editable PDF with a tab will be more convenient, save space, and it will save the cost, right? Many savings, right? So computer-based systems are faster, saving time, money, and it's accurate as well. And it can be easily secured, right? It can be easily secured. For an example, in case of flood, fire, or in case of terrorist attack, there's a high tendency to damage data in the manual system. You can't recover them back. So for an example, I don't know whether you have heard of, we had a great library in Jaffna, But unfortunately, due to this civil war, which has happened few years ago, 30 actually, we had like 30 years of long duration. So due to that, we lost that. Right? Somebody, I don't know the responsible party, but somebody has destroyed that library. The entire library, that is the biggest library in Southeast Asia, was vanished. The entire library was vanished, right? So, but that could be saved in case if it was electronic library, it was easy to keep a backup. But if it is a manual system, it's very difficult to keep a set of copy or backup. We don't have backup, so we lose that. But if it is an electronic system, it's possible to keep a backup. So those are the things that you should know when comparing these two systems, manual systems and electronic systems. Right, okay, so again, I would like to ask one question from you, right? So can any one of you tell me what is, what is the most valuable resources, economic resource in the world? Is it gold, or is it platinum, or is it crude oil, anything? So what is the most valuable economic resource in the world? Yes? What is the most valuable economic resource in the world? Okay, forget about that question. Who is the number one? Who is the number one or the richest person in the world now?
Elon Musk.
Sorry?
Elon Musk.
Can you spell out?
ELO.
He's CEO of Tesla. He's having 163.9 billion. CEO of Tesla having 163.9 billion by 2021. So Jeff, he's having 183 billion. So who's the topmost now?
Jeff Bezos.
Jeff Bezos is the topmost, right? Okay, top 10, let's say top 10 richest people in the world in 2021. So it is, the first one is Jeff. So now it's raised to 193, is 93.4 billion. So, and Elon is, he is the second, and then Bernard Arnault and family. So it's Bernard Arnault and family, 155 billion, and Bill Gates, and fifth is Mark Zuckerberg, right? So this is the story, right? Jeff Bezos is the number one. It has changed by 2021 because Bill Gates was number one a few years ago, but he has become number 4, and Jeff became number 1. So what is the job of Jeff Bezos? Jeff, what he's doing?
Owner of Amazon.
Yeah, he's the founder of
Amazon.
Founder of Amazon. What Amazon does?
Online delivery shipping.
Sorry?
Online deliveries and
Online, yes, online. It's an online market, e-business. Okay, so do they have stores?
No.
Stores? Not actually. So from where they buy goods? How they sell products and services?
from other companies.
Yeah, other companies are selling over there. No? Other companies are selling. So they have stores, but Amazon, they don't maintain. Right, Amazon, but they might have. But so mostly, they are not maintaining a big, like they are not maintaining a big stock. Instead of that, other companies are selling over there. Other companies like eBay. So eBay is also kind of market. So where eBay doesn't, they don't have stocks, but others are selling. So buyers also from all around the world. Amazon also the same story. So what they have, what Bill Gates, what Mark Zuckerberg is selling? Is he selling products, goods, or any service? So what Mark Zuckerberg is selling? Yes, he's the owner of Facebook. What he is selling? Yes. Anything? Gold or crude oil, vehicles, mobile phones? What he is selling? Joel? Yes.
He don't sell anything.
He don't sell anything. Praveen?
The software.
Is he selling software? I don't think. So Microsoft is selling software. So Microsoft is selling software, but Bill Gates selling content. Selling content. Content of whom? Do they have content?
Content from others.
Content from others. So there is a space to share content, your content and my content, our family content, the photos, all these, everything is there. So how he earns? Because he has a big network. He has a big network and he is providing infrastructure to them to share the content. And others who wish, the business people who wish to advertise over there can come and advertise because there are millions of people. So as a continent, okay, so let's say Facebook as a continent. So Facebook as a continent. So well, let's say Facebook population as a continent. But if you take, so you can see, so still I'm not getting the exact result that I want. Facebook, let's say Facebook population was continents. Okay, you can see here. So if you take Facebook as a country, right? If you take a Facebook as a country, this is the area that captured by Facebook. If you take Facebook as a country, okay, so you can see here, if you take Facebook as a country, right, how big the social networks, right? USA, so you can see the billions. So Facebook has 1.6 billion plus. China has 1.3 billion or closer to 1.4 billion population. So Facebook is even bigger than China. China is the largest, but Facebook is even bigger than China, even bigger than India. So WhatsApp is even, WhatsApp and Instagram bigger than USA, right? WhatsApp and Instagram bigger than USA. So think about the population over there. So information of people, right? Or the users. So they are having information of people and users. So Facebook is selling that content. Facebook is selling the network. So that network is covering, so more than like 1/3 of the world. It's covering more than 1/3 of the world. Facebook, WhatsApp and all. So that is the infrastructure that they are selling, no content. Okay, then, so I want to ask the question. So what is, so think about Jeff Bezos, think about Mark Zuckerberg. Okay, now tell me what is the most valuable, economic resource of the world? Now you can answer this question. What is the most valuable economic resource of the world? Yes? Yes, come on. What is the most valuable economic resource of the world? Sorry,
Network.
network. Physical network or information network?
Information network.
Yes, information network. So what population? Physical population or information using population using information? So anyway, so ultimately the answer will be information. Answer for this question is information. If you have information of people, you are rich. If you have information of population, you are rich. If you have information about software, you are rich. If you have information about the world, some factor, if you have information about COVID-19, if you have recipe of COVID-19, recipe of not COVID-19, if you have recipe of maybe antivirus related to COVID-19, a very good tested recipe of antivirus. Or if you know the way to develop antivirus to attack COVID-19, so you are rich. You will become one of these guys. So because what these guys are having, what Microsoft is having information, what Jeff Bezos is having information, what Facebook's having information, none other than that. So it's critical. So such a critical, valuable resource needs careful engineering. Such a critical and valuable economic resource need careful engineering. So software produces information. So because of that, you need careful engineering, and that's why we have system development life cycle. That's why we have SDLC, system development life cycle. So please write down this. These are very important factors, red color factors, because information is most valuable economic resource, because information people are in the topmost ranks in the world, because the people who are dealing with the information are the richest people. So information is the most valuable resource. Such a critical product need careful engineering, and that's why we have system development life cycle, to carefully engineer this with series of steps. It will engineer a system with a set of carefully defined series of steps by a team. It will engineer a system with a set of carefully defined series of steps by a team. So that is why we need this. Okay, please write down this and let me know once you are done, then I can continue to the next. So now, so we know the system, so why it need engineering process and all. So let's go and learn. So what is this? What are these steps? So here you can see the steps in SDLC. Actually, this will not take much time, so we can finish this within, so surely within next day we can finish the lesson, right? This is a small lesson, so having a theoretical part. But we should know what is SDLC and what are the steps in SDLC, why these are important. Actually, I'll tell a background, I'll share a background story, or I'll share example related to this. Then you can understand the requirement or need of the system carefully. Steps of SDLC. So I'm going to add few steps. So so you can refer to the book content when you're writing for the exam. You can just write the book content, that is enough. But I'm going to add few more steps to this. Steps of SDLC. The first one is requirement analysis. Requirement analysis. The first one is requirement analysis. requirement analysis. Second one, sorry. Number 2 is, so after requirement analysis, let's go to number 2, that is feasibility, sorry. So sub-step, actually this is a sub-step of requirement analysis that is called feasibility study. Right? So actually I missed one thing. I'm really sorry for that. I missed one thing, that is actually even before that, the initial step is problem definition. That is not listed in your book even, right? Initial step is problem definition. So then you have the step number 1, which is requirement analysis, and the step number 2 is, step number 1 is requirement analysis, and step number 2 is system design. Step number 2, 3 is coding and system development. And step number 4 is system testing. Step number 5, deployment, implementation, and deployment. If you are disconnected with this session, please reconnect to the same link, right? If you are disconnected with this session, please reconnect to the same link. Step number 6 is